So we started off with the GCF and we said that there are 4 types. We already covered when they have matching set of parentheses or a common polynomial. The second version, part B, is when you have a common variable. So when you have a common variable, notice that here we have a trinomial. What we're going to do to see if there's a GCF is look for a letter that all terms have the same. So notice that we have 3 terms. Remember, minus or addition signs separate terms. You're going to look to see if every single term has the same letter. If every item has the same letter, we definitely know we have a GCF. So notice M, M, M. Now if this was a P and you had M, M, P, then there would be no common variable for the 3 terms. Even though 2 terms might have M's, if this last term did not have an M, we don't have a GCF for a common variable. Luckily, this guy, all of them have the letter M. Once we see that they have the same letter for all terms, then what we're going to do is grab the smallest exponent. The variable and the exponent will be part of the GCF. So notice here we have m to the 7th, m to the 5th, m to the 4th. So our smallest amount looks like m to the 4th. So I know my GCF is going to be m to the 4th. Now I created this problem that I know that they would not have anything else in common. You cannot factor 3, 11, or 7, so the only GCF is that matching letter and its exponent. Now to factor it out, this is only finding the GCF. What we need to do for the test is to factor him out. Once you find out what the GCF is, take your GCF and divide each and every term by the GCF that you just found. So m to the 4th, m to the 4th, m to the 4th. To get your leftovers, it's basically doing that quotient rule that we talked about in the last unit. Remember, we have 7 m's on top, 4 at the bottom. Remember the 2 questions that we always ask? Where do you have more like on top or bottom? And by how many more? So you can clearly see I have more m's on top by an extra 3. When you do the GCF, you'll always have more on top. By grabbing the smallest number, it's a guarantee that you'll always have more on top, or that there'll be a tie where they'll all cancel out. You should not have more variables at the bottom. So when I do this, 7 versus 4, I know that I'm going to be left with 3 on top. 7 versus 4. And over here, m to the 5th and m to the 4th, there's going to be an extra m on top. So negative 11m. You don't have to put a 1 here. You can leave it without the 1. It's understood that there's 1 left over. And here, m to the 4th and m to the 4th, they cancel out. Anytime there's a tie, all the m's are gone, but we still have the coefficient of plus 7. The reason why you want to put it as plus 7 is because when you distribute this out, this times this, you're going to get the original. This times this, you'll get this. And this times this, you're going to get this. Let me do one more problem with this. When you have maybe 2 letters, this had all m's. Well, what happens if we have something that has maybe 2 different variables, not all m's? Let's do a's and b's. 5a to the 5th, b 3rd, minus 7a to the 6th, b squared, and plus 13a to the 4th, b to the 4th. Okay. Very unusual problem that I have up here, but just to demonstrate all the steps. The first thing that we would always do to look for a GCF is to see if you have matching set of parentheses. That was part A, which we don't have any parentheses at all, so we can skip that. Part B is to see if there's a letter that is the same in all terms. Now notice we have 1, 2, 3 terms. When I look for a common letter, I'm not looking for the same variable parts. You can see all the variable parts are different. what I'm going to look for is just that, do they all have the letter A? Or do they all have the letter B? If so, then you know you have a GCF for letters. Notice we have 5 A's here, 6 A's here, 4 A's here. So we definitely have a GCF. And that GCF for letters is A. And then remember, grab the smallest exponent for A. 5 versus 6 versus 4, 4. For B's, notice they all have B's. 3, 2 of them here, 4 of them here. So here, I'm going to grab the 2. So that it's not necessarily have to be all in the same term. Here I grab the smallest A's. Here, in this term, I grab the smallest B's. Once you find out your GCF, just like we did before, you're going to divide each and every term by the GCF. Now I know 5, 7, and 13 are prime numbers, so I know I don't have a common number. So let's divide each term by A4b squared, A4b squared, A4b squared. And then here, again, where do you have more? Should always have more on top. By how many? 5 versus 4, extra A. For B, looks like an extra B. So we're going to have 5AB here. You don't need the ones, but if you like to put ones there, that's fine. For the next term, notice 6A's versus 4A's. So there'll be an extra 2A's, so A squared. And for the B's, there's a tie. Not more on top, not more on the bottom. When there's a tie, all the B's cancel out. For this third term, we're going to get the plus 13. And then notice 4A's, 4A's, there's a tie, so they cancel out. But for the B's, 4 versus 2, extra 2 left over. So you can see here, this is going to be your answer. If you multiply this whole term with this times this times this by distributing, you should always get your original. That's another way that you can always double check when factoring, is multiply this out to make sure that you get your original answer.